Hey there, and welcome. Today, we're going to crack a secret code. A code that describes some of the most common and beautiful shapes you see all around you. These incredible curves that are secretly powered by quadratic equations.
I mean, have you ever really stopped to think about it? When you see a basketball swish through the hoop, or the arc of water from a fountain, or even the shape of a massive satellite dish, they all share this exact same perfect, predictable curve. You might think it's just a coincidence, but nope. It's actually a sign of a hidden mathematical rule pulling the strings behind the scenes.
So, that beautiful, graceful arc? It has a name. It's called a parabola. And that hidden rule that's governing it? Well, that's exactly what we're here to figure out today.
All right, you ready? Let's get into it and start cracking this code. In this first part, we're going to unveil the single equation that describes every single one of these curves.
And here it is. This is the secret code we've been talking about in what we call its standard form. ax squared plus bx plus c equals 0. Now, the word quadratic might sound fancy, but all it really means is that the highest power of your variable, in this case x, is 2. That little square term is the key. And a can't be 0, because if a was 0, poof, that whole x squared part just vanishes. And it's not a quadratic anymore, is it?
The best way to think about A, B, and C is like they're the control dials on a machine that draws this curve for you. You can see it right here. A is the big one. It controls how wide or narrow the curve is, and whether it opens up like a U or down like an upside-down U. Then you've got B, which kind of shifts and tilts the curve around. And finally C, that's the simple one. It just tells you where the curve hits the vertical y-axis.
Okay, so we've got the code. That's great. But now what? How do we actually use it to find answers, or what mathematicians call solutions? Well, for that, we have a toolkit with 3 really powerful methods. Let's take a look at each one.
Our first tool is called factorisation, and I like to think of this one as the clever, elegant shortcut. When an equation is set up just right, this is often the fastest and cleanest way to find the answer. It's all about breaking down the big equation into 2 simpler parts that are multiplied together.
So let's walk through an example together. X squared minus 5x plus 6 equals 0. The first step is a little puzzle. We need 2 numbers that multiply to get positive 6, but add up to negative 5. A little thought, and you get negative 2 and negative 3. So for step 2, we just rewrite the equation as 2 simple brackets. Now think about it. For that whole thing to equal 0, either the first bracket has to be 0 or the second one does. That's step 3. And that gives us our 2 solutions. X can be 2 or X can be 3. Simple as that.
But here's the thing about factorization. It doesn't always work, especially when the numbers get a little messy. For those moments, we need the master key. This is the quadratic formula. It's a universal tool that will solve any quadratic equation you can throw at it, every single time.
Okay, I know what you're thinking. That looks a little scary. But trust me, it's way simpler than it looks. It's really just a recipe. You look at your equation, you find your a, b, and c values, and you just plug them into the right spots in the formula. Then you just carefully do the arithmetic. No puzzles, no guesswork, just a clear road to the answer.
Now that formula is a powerhouse, for sure. But what if I told you there's a secret hidden right inside it? A little shortcut that can tell you what kind of answer you're going to get before you even do all the math.
Well, there is. It's called the discriminant. It's just that one little piece of the formula under the square root sign, b squared minus 4ac. The value of that one part tells you the whole story. If it's a positive number, you're going to get 2 different solutions. If it's exactly 0, you'll get just one solution. And if it's negative, well, you can't take the square root of a negative number, so there are no real solutions. It's an amazing little predictive tool.
All right, on to our third and final tool, completing the square. Now factorization is fast. The formula is powerful, but this one is special. This is the method that really shows you the why behind it all. It gives you this deep, almost visual feel for how the equation is structured and why it all fits together so perfectly. So let's break it down with this example. First things first, you just move that constant number over to the other side. Now for the key move, we complete the square. You take the middle number, 6, cut it in half to get 3, and then square that to get 9. You add that 9 to both sides. Why? Because you've just magically turned the left side into something called a perfect square, which factors down beautifully into x plus 3 squared. And from there, it's easy. You just take the square root of both sides and solve for x.
Okay,
we've got our toolkit. We know the methods. Now for the fun part. Let's actually put this stuff to work on a real problem, just like the ones we talked about at the very beginning.
So here's the setup. We've got a ball that's been launched into the air. This equation right here describes its height, h, at any given time, t, and the question is pretty straightforward. At what time does the ball finally come back down and hit the ground?
And this right here is the most important part. We have to translate the question into math. When the ball hits the ground, what's its height? Well, it's 0, right? So we just set h to 0 in our equation. And look at that. We get negative 5t squared plus 20t equals 0. That's a quadratic equation we know how to solve. For this one, factorization will work like a charm.
So when we solve this, we actually get two answers. The first one is t equals 0, which makes sense, right? The ball was on the ground at the very start, before it was launched. The second, more interesting answer is t equals 4, so the ball lands after being in the air for 4 seconds. See? The quadratic code gave us the exact answer.
And you know, this isn't just a random math problem. Understanding this code, this beautiful curve, it really unlocks a whole new way of looking at the world around you. Let's zoom out and see why this matters so much.
I mean, think about it. Engineers use this stuff to design the curve on a satellite dish to focus signals perfectly. Financial analysts model profit curves to find the point of maximum return. Physicists plot the path of a rocket. These equations are absolutely fundamental tools for describing how things move, how they're shaped, and how we can optimize them.
And that, I think, is the real magic here. It can seem a little complicated at first, but once you learn the rules of the toolkit, it just becomes this fun puzzle. You see the problem, you recognize the pattern, you pick the right tool for the job, and you find the solution. And once that clicks, you can't unsee it. You'll start noticing these parabolas absolutely everywhere.
So that leaves us with one last big question. We've cracked the code for these curves, but that's just one piece of a much larger mathematical universe. It really makes you wonder, doesn't it? What other parts of our world are secretly being run by math, just waiting for us to find the right code?